Hi, this is Professor Evans. This video is for the students of COP 1000C, which is Intro to Programming Concepts at Valencia College in Orlando, Florida. In this video, I'm going to do some examples related to Unit 4, which covers Control Structures 1, and that's going to focus just on selection. Here are your Unit 4 learning objectives for this particular unit. You're going to learn how to identify and use control structures, identify logical and relational operators, how they work, and their order of precedence. You're going to learn how to distinguish the relationship of relational operators and simple data types. You're going to learn how to identify and how to form and evaluate logical or Boolean expressions. You will learn how to use one-way and or two-way selection syntax. You'll utilize pseudocode to develop, test, and debug a program, demonstrate a switch statement in a program. You'll learn how to identify bugs and how to use the assert function to terminate a program. So in today's video, I'm going to go over 3 examples that are going to help you learn the fundamentals behind the idea of selection, which basically means using if statements or if-else statements, as well as using a switch statement. So to begin, I'm going to start our first program. If you've been following along with previous videos, I have a different compiler today because I'm having some technical difficulties with the usual compiler that I use. But you can follow along with me with your computer at home using any compiler that you'd like. Okay. In this program, we're going to read a customer's name, a purchase amount, and a tax code. The tax code will be one of the following options. 0, which means you are tax exempt, and your tax rate is 0%. The tax code could be a 1, which means you have state sales tax only, and that tax rate is 3%. The tax code could be a 2, which means you have federal and state sales tax that has to be applied at a rate of 5%. Or the tax code could be 3, which is a special sales tax rate at 7%. So we have these different options for the user to enter their tax code, and so it'll be a digit 0, 1, 2, or 3, and depending on that code that they type in, we'll have to apply a certain amount of sales tax to the purchase amount. So the program will compute the sales tax and the total amount due. It will print the customer's name, purchase amount, sales tax, and total amount due. So let's talk about our inputs and our outputs. Our inputs in this case are going to be the customer name, which is going to be a string. We have the purchase amount. Since that's going to be a form of currency or an amount of money, I'm going to go ahead and make that a double. We have the tax code. Looking at the program objective, we can see that the tax code is going to be an integer. So I'm going to define that as an integer. And those are going to be my inputs. My outputs for this program are going to be the customer name, because I'm going to print that out. I'm going to print out the purchase amount. Again, that's a double. I'm going to print out the sales tax. And I'm going to print out the total amount due. Now let's talk about our process in order to collect this information and then print out the required outputs. So the first thing I'm going to want to do in my process is collect all the inputs from the user. So after we define our variables, we'll use some CIN and COUT statements in order to collect the inputs that we need from the user. Once we have those inputs, the next thing we're going to need to do is calculate the sales tax. So here's where we're going to use selection, meaning a series of if statements, in order to determine the sales tax. Basically, what we want to do is we want to say if the code is 0, apply a rate of 0%. If the code is 1, apply a rate of 3%. If the code is 2, apply a rate of 5%. And if the code is 3, apply a rate of 7%. So we're going to use selection, meaning we're going to use if statements in order to determine how the tax code selects the tax rate to be applied to the purchase amount. So here's what our if statements would look like if we were going to use selection to calculate the sales tax. We need an if statement that's going to look at tax code and determine what value it is, and then take an action based on that value. We want to start with our first case. If the tax code is 0, we need to apply 0% sales tax. Now, whenever we write an if statement and we want to compare the variable on the left to a value, if we want to know if those two things are going to be equal, we have to use a double equal sign inside the parentheses here. That's really important for your syntax. So whenever we're writing an if statement, if we want to know if a particular value is equal to something, we have a double equal sign right here inside the parentheses. Then on the right side of this expression, we write what we want to see if tax code is equal to. In this case, we want to see if tax code is equal to 0. So we're going to have a double equal sign right here in order to make that comparison. On the next line, whatever we write on the next line will only happen if the condition inside the if statement is true. If tax code really is 0, then the next line of code is going to execute a particular task. In this case, if the tax code is 0, we want the sales tax to also be 0. So this line will only happen if this statement evaluates to be true. If it is not true, sales tax will not be set to 0. Next, we want to check if the tax code is 1. So in order to do this, we can say else if, and then we're going to say tax code is equal to 1. So if tax code does not equal 0, we're next going to check and say, well, is tax code 1? Keep in mind that an else if does not even become evaluated unless we start with the if statement. So what that means is we're not going to look at tax code being 1 until we first look at if tax code is 0. If tax code is not 0, then we come down here and we evaluate whether or not tax code is 1. So this runs sort of sequentially. We're first going to evaluate whether tax code is 0. If it's not 0, then we're going to look and see if tax code is 1. If tax code is 1, we want our sales tax to equal 3% of the purchase amount. So in this case, our sales tax is going to be our purchase amount times 3%. That's going to give us the amount of tax that is owed if our tax code is 1. Let's keep going. Well, what if our tax code is not 1 or 0? I need to check to see if the tax code is 2. And if it is 2, we now know that our purchase amount has to be multiplied by a federal and state sales tax rate of 5%. So now I'm calculating the tax if my tax code is 2. And then we're going to check to see if tax code is 3. And that's where we have that special sales tax rate of 7%. So this is going to be our algorithm to use selection to look at the value of tax code and take an action based on the value that is supplied. If the tax code is a 0, sales tax will be 0. Else, if the tax code is a 1, then the sales tax will be equal to your purchase amount times 3%. If the tax code is a 2, our sales tax will be the purchase amount times 5%. And if tax code equals 3, our sales tax becomes the purchase amount times 7%. This is all per the directions provided above. So now that we have sort of our algorithm for how we're going to calculate the sales tax, once we have the sales tax, the next thing we're going to do, or the next step in our algorithm, is going to be to determine the total amount due based on the sales tax that was calculated. So in this case, once we know what that sales tax is, our total amount that is going to be due is going to be equal to the purchase amount plus the sales tax that we calculated. So that's going to give the user the total amount due, that purchase amount plus the sales tax. And then our last step in our algorithm would be to print the outputs for the user. And that would be, again, relying on the program objective and knowing that it will print the customer's name, purchase amount, sales tax, and total amount due. So those are the things that we're going to print when we're done. Now that we have our algorithm and our process defined, we're going to go ahead and start writing our code. Since I'm going to be capturing the user's name, the customer name, I need a string to save the customer's name. Therefore, I have to have the #include string statement at the top so that I can use that string as a variable type and store the customer name. Since I'm also dealing with money and amounts, I am going to go ahead and use the #include IO manip so that I can display everything in dollars and cents. All right, let's begin by declaring some variables. So I'm going to have the name, the customer name, as a string. I'm also going to have the purchase amount, sales tax, total amount due as double values, and then tax code is going to be an integer. Again, I can refer back to my thought process up at the top when I defined the inputs and outputs to make sure that I stuck to my plan. So I should have customer name as a string. I'll go ahead and make this customer name as a string. The purchase amount is a double. Tax code should be an integer. Then we also have sales tax and total amount due as doubles. Now that I have declared my variables, I am going to collect the inputs. So there's the customer name. And there's my tax code. Now we're going to calculate the sales tax. And in order to do that, I've already written out my algorithm right here. So I'm just going to go ahead and bring this down. All right, so I've got my algorithm right here to calculate the sales tax based on the tax code. Next, I'm going to determine the total amount due. I've also written down my algorithm for figuring out that amount. It's right here. So I'm going to copy and paste my total amount due calculation right down there. Lastly, I'm going to go ahead and print the outputs. Since I want to display the purchase amount, the sales tax, and the total amount due as dollars and cents, I'm going to go ahead and set the precision, just like that. And then I'm going to proceed to print my outputs. Since my sales tax and purchase amount are dollars and cents, I'll go ahead and add a $sign at the end of the text before the value is printed. So I'm going to add my sales tax due right here, and I'm going to display the total amount due. And that will complete my program. So now I'm going to go ahead and compile and run. So I'm going to go right up here and hit run. And I see that I have an error. Compilation failed due to the following errors. So take a second, see if you can figure out what I forgot. Hopefully you noticed that I did not add this line before I began the main program. Let's go ahead and compile again. Now I have another error. Let's try to figure out what I did wrong. Right here, I used cin name, but I actually called my variable customer name. So it doesn't recognize what name means. I need to make sure that I use the same variable name throughout the program that I used when I defined it. So customer name is what should go right here. I'm going to go ahead and look and see if I made that same error anywhere else. I can see that down here I did use customer name. So let's go ahead and try again. All right, now that I've fixed my errors, I'm going to go ahead and type in some information. So to begin, let's say that the customer's name is Sharon. Let's say that the tax code in this case is going to be tax code 2. And here's what I got. Take a second and try to figure out what's gone wrong. Purchase amount, $0. Sales tax due, $0. Total amount due, $0. So I entered my tax code, but I did not get an opportunity to enter in the purchase amount. So this is what we call a logic error. The code compiled after I fixed my initial errors. It compiled, but it still doesn't work the way I want it to or the way that it was intended to. These are called logic errors. They're not going to be caught by the compiler. They're going to be caught essentially by your brain. So I can see here that I was able to enter a name, but I never was able to enter a purchase amount. So if I go back to the top where I collected the inputs, I can see that I collected the customer name, I collected the tax code, but I never actually gave the user an opportunity to enter the purchase amount. So I'm going to add that into my code right now. So now I have added the code that I need to actually enter a purchase amount so that the user can figure out what the total price is. So let's try and run again. So let's try this again. I'm going to enter in the name Sharon. Now I have an opportunity to enter the purchase amount. I'll enter in $100. And I'm going to enter a tax code of 2. If I enter a tax code of 2, according to my program objective, that means I should have federal and state sales tax of 5%. So now I can see that it's printed the outputs. The customer name is printed, Sharon. Purchase amount, $100. Sales tax due, $5. That would be 5% of 100. And I can see that my total amount due is $105. Let's go ahead and run this again and do some other test cases. Let's say that my customer's name is Bill. Let's say that the purchase amount is $50.75. Let's say that the tax code is 0. That means I should have no sales tax. And I can see that the sales tax due is 0, and I have a total amount due of exactly what I entered in. So we've checked that when I enter a tax code of 0, it works. When I enter a tax code of 2, it works. Let's also check the remaining cases. Let's check that a tax code of 1 works and that a tax code of 3 works. Let's say that my customer name now is Danny. The purchase amount is going to be $10. The tax code is 1, so I should have 3%. So 3% of $10 would be 30 cents. And I can see my total amount due is $10.30. One more run to check the special sales tax rate. There's my customer name. The purchase amount is going to be $1,000. And I'm going to enter in tax code 3. So now I can see that 7% has been calculated as the sales tax due, and I have my total amount. So I've tested all of my tax codes, and it works. Let's do some more. What if I were to enter in a first name and a last name? And I hit enter, and what happens? Here's what I entered. I didn't get a chance to enter in anything else, and the program printed out all values of 0 and exited. That's because whenever we have a string, right here, when we take in the customer name, it's only going to read in what you type until it hits the first white space. So it's going to read the name Brandon. As soon as you hit a space, it is done reading that customer name. At that point, Brandon, the characters in Brandon are what are supplied next. and it's not going to read, the characters after Brandon that are supplied next are not going to be read in. And that is because of the way that strings work. So in this particular program, we can't enter in two names unless we program it that way to accept two names. We have to have a workaround for looking for that white space and ignoring it to collect the last name. In this case, this isn't a part of the program objective, so I'm not going to solve that here, but I am just pointing out that you will get an error if you try to enter two names because you haven't programmed it that way. When we get to Chapter 8 and we learn more about working with strings, you'll learn more ways that you can use to work around this problem so that you could redo this code, but take in both the first name and the last name. Another thing I'd like to point out, if you hit run, I'm going to type in the customer's name, purchase amount. Now, what happens if I enter a tax code of 8? So let's talk about why the sales tax came out to be 0 when I entered in an invalid tax code. We go back to our code and we look at our selection statements. Right here are if-then statements. What we're looking at here is we've only provided certain options for tax code to be. If tax code is a 0, the sales tax should be 0. If tax code is a 1, the sales tax should be purchase amount times 3%, and so on. In our case, is tax code a 0? No. Is tax code a 1? No. Is tax code a 2? No. Is tax code a 3? No. None of these lines executed. Line 58 didn't execute, line 60 didn't execute, line 62 didn't execute, line 64 didn't execute. None of those things happened because none of the conditions in each if statement were true. So essentially, when this code was run, all of this was skipped. But because we declared sales tax and never put anything in it outside of this if statement, sales tax came out to be 0. So let's say that when I declare sales tax, I'm going to let sales tax equal $1. I'm just going to make that small change, and I'm going to do the same thing again. I'm going to have Marcus. He's going to have $567.99. The tax code is going to be 8. And now we can see what I'm trying to prove, which is basically that nothing down here ever ran. And because we never stored anything in sales tax anywhere else, it came out to be a 0. 8 is an invalid code, and it's not going to execute any of these options. But because we didn't do anything else to prohibit the user from entering an 8, we're going to get sales tax to be exactly what we defined it as. We gave it an initial value, and then we never changed it. So this if statement covers our 4 cases for tax code being 0, 1, 2, and 3, but we've done nothing to cover the case of, well, what if the user enters something else that's not 0, 1, 2, or 3? So if that's something that you would want to cover, you could change your code to also consider if the user enters something and they shouldn't. For example, let's say that we want to make sure that the user will only enter a 0, 1, 2, or 3. I'm going to go back and take that $1 out of my sales tax. All right, so if the tax code is not 0, and it's not 1, and it's not 2, and it's not 3, we can have a final else. We can send a little message to the user. We can say, hey, please enter a tax code that is 0, 1, 2, or 3. So how this is going to work now is we're going to evaluate tax code. We're going to say, if tax code is a 0, do this. If it's a 1, do this. If it's a 2, do this. If it's a 3, do this. This final else means basically for all other conditions. If tax code is anything else besides the conditions we've already stated, then this action is what is going to happen. So now let's experiment with that. Let's try it out. So I'm going to hit run. And the customer's name is Adrian. The purchase amount is $599.34. Let's say that I put a tax code in of 10. Now I get a message that says, please enter a tax code 0, 1, 2, or 3. So I'm letting the user know, hey, your tax code is not valid. You'll notice, though, that my see out statements are still printing at the bottom, and that's because these don't have a condition on them. These are going to print regardless. They're going to print every single time you run the program. So if I wanted to control that so that it would only print if there was a valid tax code, perhaps I would have to add another statement so that I could control the outputs so that they only print when I want them to. For example, we could add another if statement right here. So we could say if tax code is greater than 3, meaning they entered something larger than 3, less than 3. So the tax code is going to be 0, 1, 2, or 3. That means it'll be a number less than 4. So as long as the tax code is less than 4, we can print the information related to their purchase amount and sales tax. Now keep in mind that if you're going to have an if statement and you want more than one line of code to execute when your statement is true, you need brackets around that particular section of code. So for example, if I want all 4 of these outputs to print, as long as the tax code was entered as something to be less than 4, I need a bracket around the entire section of things I want to have happen. Without the bracket, this line is the only line that will execute if tax code is less than 4. The rest of these lines aren't attached to the if statement without those brackets. So I want to make sure that if I have more than one line of code that's supposed to execute based on the condition of an if statement, I want brackets around it. So all 4 of these now are controlled by this statement. So let's try this one more time. Now let's say that I enter that incorrect tax code. Let's say I entered 10. Now I just get one message that says, please enter a tax code 0, 1, 2, or 3. And I don't get the extra printout at the bottom because I can't print it. The user didn't give me a valid tax code. So this is just a quick example of how we can implement some error checking so that we can make sure that users enter in correct values in order to run the program the way it was intended. So that is the end of the first example. If you're following along on your own computer, go ahead and save this as example 1. And then I'm going to continue with the same program objective, but we're going to implement it now using a switch statement instead of an if statement. So we're going to leave pretty much everything the same, except now I'm going to put a switch statement in instead. And this is going to now become example 2. So example 1 is just using if statements, and example 2 is going to accomplish the exact same thing, except now I'm going to use what's called a switch statement. So I'm going to go ahead and comment out my if statement. I'm not using that right now. I'm going to just leave that alone. I'm commenting that out of my code, and I'm going to calculate the sales tax using a switch statement instead of if statements. So here's what a switch statement looks like. You're going to use the keyword switch, and then you're going to enter a variable name. In this case, I want to use tax code because I'm checking the value of tax code, and then I want to take an action based on what tax code is. So tax code is the variable that goes inside the switch statement. Now I'm going to use the keyword case. You can think of case the same way you would think of if something equals something else. So right now, our switch statement is saying use tax code for each case. Case 0 means if tax code equals 0, then we're going to do something. And after the colon, we write what we want to do. So in this case, if tax code equals 0, we want sales tax to equal 0. And then you're going to type the word break, which basically means stop running the switch statement. I'm done. I don't have any other actions I want to take. Exit the switch statement and then continue executing the code that comes directly after. That's what that word break is telling us to do. Our second case is if tax code is a 1. If tax code is a 1, I want the sales tax to equal the purchase amount times 3%. And then I want a break because I've calculated the sales tax and I don't need to keep running through the rest of this case statement. I'm done. So we use that word break. Our third case is if tax code equals a 2. So keep in mind, whatever goes here is what tax code will be compared to. Since tax code is an integer and we know that it's going to be 0, 1, 2, or 3, we're saying take tax code, and if it's a 0, do this. If it's a 1, do this. If tax code is a 2, here's what we want to do. Purchase amount times 5% and exit the case statement. And our final case is if sales tax is equal to, if tax code is equal to 3. If tax code is equal to 3, we're going to have our sales tax become purchase amount times 0.07 and break. Now, this is how we can set up our case statement. The nice thing about a case statement is that it also comes with what we call a default action. Okay. So by default, if tax code is not 0, and it's not 1, and it's not 2, and it's not 3, we have to give a default condition. What do we want to have happen if sales tax isn't 0, 1, 2, or 3? So if tax code isn't 0, 1, 2, or 3, we want to display that message to the user to let them know, hey, you have an invalid tax code. So I'm going to do a cout statement right here. And I'm going to send them a message. You can decide what the message would say. I'm just going to say, this is an invalid tax code. Please try again. And then we'll break. This concludes our case statement. It does the exact same thing as our if statement. It's going to take tax code, evaluate the value of tax code based on these cases, and take an action. And if tax code is not any of these values, I'm going to get a message saying that it's an invalid tax code. Let's go ahead and run this and see how that works. Let's say that I enter in just some really long random number for the tax code. And I get a message, this is an invalid tax code. Please try again. Now let's say that I run this again. The purchase amount is $10,000. Let's say that the tax code is 3. And I can see now that it's running the way that it should be. So this is how we can use a case statement instead of if statements to accomplish the same thing. The idea of selection. Selecting an action based on the value of a particular variable as you run your code. So that is going to wrap up example number 2, where we implemented this sales tax calculator using the case statement instead of the if statements. All right, so I'm going to now delete all of this code and move on to our final example for this video, example number 3. The program objective is going to be related to credit card billing. suppose that we have billing amount is a double variable, which denotes the amount you need to pay to a credit card company for a balance that is due. So you have a credit card, you put money on it each month, now it's time to pay the bill. Billing amount is how much you owe, and it is going to be a double variable. So here are the payment conditions. Okay, so we have payment condition A. If you pay the full amount, you get $10 or 1% of the billing amount, whichever smaller, as a credit on your next bill. If you pay at least 50% of the billing amount, you have a penalty that is 5% of the remaining balance. Or C, if you pay at least 20% of the billing amount, but less than 50%, you have a penalty that is 10% of the remaining balance. Otherwise, so if you do not fall into category A, B, or C, otherwise, the penalty is 20% of the remaining balance. So if you pay less than 20% of your billing amount, your penalty is going to be 20% of the remaining balance after your payment is applied. So the goal is to design a program that prompts the user to enter the billing amount and the desired payment. The program is then going to calculate and output the credit, if they got one, or the remaining balance if the amount is not paid in full. The program should also output the penalty amount. So that's our program objective. Let's talk about inputs. We know we're going to have billing amount. That's going to be a double. We're going to have the user enter their payment as a double. Our outputs in this case are going to be the credit they get if they earned one. That'll be a double as well. Their remaining balance as a double. And the penalty that they owe, also a double. We've got all monetary values here. We're going to make them all doubles so we can display everything as dollars and cents. Now let's talk about our process. How are we going to create the algorithm to implement what we see here in the program objective? So let's begin with, after we take the user's inputs, the billing amount and the payment, first thing we'd want to do is determine the balance on the card after payment is made. So I'm going to have a variable balance that's going to be my billing amount minus the payment received. That's going to be my balance. Based on that, I can determine if a credit was earned. So the next thing I would do is determine if a credit was earned. So how do I determine if a credit was earned? If you pay the full amount, if I pay the full amount, that means my balance would be 0. So I'd want to be able to check that. So if balance is in fact 0, then the next thing I need to determine is, do I get $10 as my credit or 1% of the billing amount, because I only get whichever is smaller of those two options. So I need to figure out how I can check that. Well, I can set up an if statement, and I can say if, and I can do 1% of the billing amount. If that value is less than 10, then I know that my credit is going to be that 1%. Otherwise, I'm going to get $10. That's what condition A says. If you pay the full amount, you get $10 or 1% of the billing amount, whichever is smaller. Let's go see what 1% of the billing amount is right here. Then let's compare that to the number 10. If 1% of the billing amount is smaller than 10, that's my credit. If not, my credit will be $10. So this right here is going to help me determine if a credit was earned. I have a nested if statement here. So keep in mind that this if statement will not even execute if this statement is not true. If the balance is not 0, then lines 22, 23, 24, 25 won't execute, and the code will continue with the line after that. That's how a nested if statement works. So the second if does not get evaluated unless the first if evaluates to true. If balance is 0, that's when we'll go ahead and determine what the credit is. Otherwise, we don't even need to run these lines of code, and we need to figure out the penalty and the remaining balance. So our nested if right here is going to determine if a credit was earned. The next thing that we're going to want to do after we determine if a credit was earned was determine the penalty if at least 50% of the billing amount is paid. That's our next step. So if we break this down, we tackled payment option number 1. Or letter A. Now we're looking at payment option B. If you pay at least 50% of the billing amount, the penalty is 5% of the remaining balance. So let's go ahead and take that idea and put it into some code. So we need to figure out, did 50% of the billing amount get paid? We need to see if that was paid. So what we're going to do is set up another if statement. If the payment, that's what the user is paying, if that is at least 50%, so it could be 50%, could be more. So we're going to use the greater than or equals to sign here. If the payment is greater than or equal to 50% of my billing amount, okay, so this is going to tell me or help me to evaluate if the payment was 50% or more of the billing amount. If it was, what do I want to do? Well, I want a penalty of 5%, and that would be a penalty on the remaining balance, So I'm going to now calculate the penalty, and I'm going to take 5% of the balance to determine the penalty. There's my balance, 5%. Now, what if I paid something less than 50%, but at least 20%? Now I'm in option C. So now I want to evaluate that condition. So I'm going to say else if. Now, if the payment is greater than or equal to 20% of billing amount, and also less than 50%. That's what we want to evaluate here. So in order to do that, I'm going to make sure that my first condition is completely in its own parentheses. So I've added an extra parenthesis here so that payment less than or equal to 20% of billing amount is in its own set of parentheses. I want to evaluate that, and I also want to evaluate whether the payment is less than 50% of the billing amount. So there's my second condition. I'm evaluating whether payment is greater than or equal to 20% of the billing amount, and I also want to evaluate whether the payment is less than 50% of the billing amount. In order to conjoin these two together so that I'm checking this one and this one, I need a double ampersand operator in the middle. That operator stands for the word and. If you've taken a digital systems class, it's the same idea. The idea of and is that something cannot be true unless two events are both true. In this case, this line number 30, will determine if payment is greater than or equal to 20% of the billing amount and the payment is less than 50%. If both of those things are true, what I type on line 31 will execute. If both of those things are not true, then line 31 will not be evaluated and executed by your code. So this is now going to help me handle payment option C. And according to the program objective, if I fall into the category of payment option C, the penalty is 10% of the remaining balance. So if I fall into this category, my penalty is 10% now. And according to the program objective, otherwise, if I don't fall into category A and I don't fall into category B and I don't fall into category C, the penalty is automatic 20%. So if I don't fall into category A and get a credit, if I don't fall into category B and pay more than 50%, if I don't fall into category C and pay more than 20% but less than 50%, that means I'm in category D. And in that case, it doesn't matter what I paid. If I don't fall into any of the categories above, I am automatically going to get that 20% penalty on my balance. And this is going to be my process for determining the penalty as well as determining the credit. Once I've determined the penalty and the credit, I just have to print out whether I have a credit or the remaining balance. So this pretty much ends my process. This is the bulk of what I'm going to do outside of collecting the inputs and then printing the outputs to the screen. So now let's go ahead and start writing the code. Let's collect our inputs. So our doubles are billing amount, payment, credit, penalty, and balance. If we go back up here, our inputs, our billing amount and payment, our outputs are credit, balance, penalty, everything is a double. Actually, I'm going to go ahead and say that this is declare variables. And then we'll collect user inputs. So we'll ask for the billing amount. And the payment amount. At this point, I can now take my process. This is my algorithm. This is all my code. I wrote it with the proper syntax to simply copy and paste it down here. So the nice thing about writing out your ideas before you write code is you start with what you think you need to do in words. That's your program objective. Then you break each piece of that down into the logic you need to implement within your code. If you use the idea of writing your process as a small piece of your overall code, when you get down to your actual code, you've got the computational part already sort of figured out, and you're ready to test it and see if it works. Just have to fix some spacing issues here. But there are my 3 steps. Determine the balance, determine if a credit was earned, determine the penalty if at least 50% of the billing amount is paid. I can go ahead and actually add a second comment here, since I also determine the penalty if at least 20%, but less than 50% of the billing is paid. And then this one is automatic penalty if less than 20% is paid. So I can update my comments there to reflect exactly what's happening line by line. Now that I know what the penalty is, the next thing I'm going to do is determine the new balance with penalty included. So I'm going to say balance is now equal to balance plus penalty. Now keep in mind that if I say balance equals balance plus penalty, I am effectively erasing the balance that was calculated right here with a new value. Whatever's on the right is going to be evaluated first and stored into the variable on the left. If for whatever reason you don't want to erase balance, maybe you think you might use it again, we would need to create another variable called new balance. And then we can store our final balance in new balance. That way we don't erase the balance we've already calculated here if you think you might want to use that value again later. So just keep in mind, I could store the new balance inside of balance, but it would erase what was there before. So here's the new balance. Now we want to display a message to the user. Basically, the user either earned a credit or they have a balance to pay, but they're not going to get both. So let's make sure that what we display to the user is either a message that, congratulations, you earned a credit, or, hey, you still have a balance that you need to pay. So let's print a message. If the credit was earned, notify the user. So if credit, basically if credit is just not 0, if credit is bigger than 0, that means they earned a credit, they made their full payment, they earned a credit, and we want to display a message. And my message is going to say, thank you for paying the full amount. You will receive a $, and then we're going to display the credit. All right, so right now we're displaying output. Let's go ahead and set up the set precision so that we can display everything in dollars and cents. So I'll do that right here. All right, so if the credit was earned, we're going to display a message saying thank you for paying in full. And here's the credit you're going to get on your next bill. Otherwise, we need to notify the user of the penalty and the balance owed. So if they don't have a credit, that means they have a balance. So I can just say else. I don't even need to say else if. Either you have a credit or you have a balance, one or the other. So if you don't have a credit, you definitely have a balance. So if you don't have a credit, you're going to fall into this category here, and these lines of code will execute to display the penalty and balance. Oops. So we're now going to display the penalty added to the next bill, and the unpaid balance. And that's going to conclude our program. So keep in mind with if-else statements, what's going to happen is first line 80 will be evaluated. If this statement is true, lines 82 and 83 will execute, and lines 86, 87, 88, 89, and 90 will not execute. They will basically be ignored. If the statement on line 80 is false, then this will happen every single time. If credit is not greater than 0, this will always happen. There's no extra condition on this. So the difference between if, else, and an else if is with an else if, we're checking a certain condition first. If that's not true, we're then going to check something else before we take an action. With the if-else statement, we're checking one condition, and if that's not true, we're automatically doing what comes after the else. So that's sort of the difference. So you want to make sure you understand the difference between an if-else statement and an if-else-if statement, as well as your nested if statements, like on lines 58 and 59. Let's go ahead and check for some errors. All right, if you look at line 68, I have one parenthesis here and one there. This is closed. One parenthesis here and one here. That's closed. I also have a parenthesis at the beginning that I need to close to encompass the whole group. That's what's missing there. And we fixed our errors. So let's go ahead and enter the billing amount. Let's say that I owe $100 on my credit card. Let's say that I am going to pay $90. So that's more than 50% of the bill. That means I should have a 5% penalty on what's left. So if I have $100 that I owe, I pay $90, I have $10 left. 5% of $10 is 50 cents. And then that 5% is added to the bill. So then I have the unpaid balance of $10.50 moving forward. Let's do another test. Let's say that I owe $456.99 and I pay the whole thing. Thank you for paying the full amount. You will receive a credit of $4.57 on your next bill. So again, the credit is determined by 1% of the balance or $10, whichever is less. In this case, 1% of $456 is $4.50, which is less than $10. So I'm going to get the credit of $4.57 on my next bill. All right, let's do one more. Let's say that I enter in a billing amount of $100 and I pay $10. Take a look at my output. It says, thank you for paying the full amount. You will receive a $0 credit on your next bill. But we didn't pay the full amount. let's try that again. Let's say that I have $5,000 and I pay $4,900. I've tested this twice and I've gotten something wrong twice. So when that happens, again, you have to look for logic errors. In this case, we would go back to our code and say, well, if I entered in $5,000 as the billing amount, and I entered in $4,900 as the payment, $5,000 minus $4,900 should be a balance of $100. And if the balance is $100, that means this should not execute, and I should have a payment. Now, if I continue down here, I notice that the only time this message prints is if credit is greater than 0. This message shouldn't print unless credit is greater than 0. But at the same time, when I print out credit, it says that it is 0. Doesn't make sense, right? So this is a great example of sometimes when we are dealing with calculations, we want to make sure we initialize our variables. We want to make sure that everything is initialized to 9 times out of 10, you're going to initialize things to 0. And this is because if we don't initialize our variables, when we declare a variable, we create space and memory for that variable to hold a value. But if we don't give it an initial value, sometimes we can get garbage or unintended values inside of our variables. And if we don't actually manipulate the variable throughout the program, we can have that garbage or that bad data still stored in that variable. And that's what's sort of happening here. We're not initializing the variables before we start, and now we're getting a really weird output that doesn't make sense, even though our logic is correct. So if you feel like your logic is correct, but you're not getting the output you think you should, make sure all your variables are initialized to a value. I'm going to go ahead and set all my doubles equal to 0, and I'm going to run this same test, 5,000 and 4,900. And now I have a penalty and an unpaid balance that makes sense. If I owe $100, 5% of $100 would be $5. And that leaves my unpaid balance equaling $105, exactly what I expect. So that's just a little note to say that if you get an output you don't expect, initialize your variables. If you're using doubles, floats, ints, initialize them with the value. Most of the time it will be 0. So that's our third example. It goes into a little bit more of the complexities of how we lay out an algorithm when we have several options that include multiple scenarios. So use this as an opportunity to practice for your coding exercises for Chapter 4. Please email me if you have questions. Thank you for watching, and I'll see you next time.